Good morning, everyone. Welcome to this RailTech Master Class. So today we welcome Axel Franzke from BASF. Axel is head of fleet management and workshops at Ludwigshafen site, which is Europe's largest chemical complex. So let's go for an introduction just while people get connected. I think we are waiting for some others. So before leaving the stage to Axel, I will take some time to introduce myself. So my name is Aurore. I'm the lead marketing manager at Everysense, and I will be your host today. For those who don't know Everysense, we are European rail freight digitalization company, and for the past 10 years, we've been working on making rail freight easier to manage for industrial shippers, and because rail is often seen as complex, opaque, it's expensive, we built a transport visibility management system, or TVMS for short, entirely dedicated to rail to help shippers control their operations from order to cash. And so think of it as an intelligent control tower for your entire rail operations. It doesn't just show you where your wagons are, but it tells you where they will be available, what the transport actually costs, and where you are quietly losing money. So just now, a quick word about RailTech Master Classes. This is basically a monthly webinar series where rail experts share their experience with rail digitalization, automation, and innovation, and it's part of our broader RailTech ecosystem, nurturing our RailTech community and also including the annual RailTech Summit, and maybe some of you already attended. And today for this webinar, I'm glad to see so many of you here. So we have registrations from 7 European countries. That's also very interesting to see that you work in different industries. So feel free to introduce yourself in the chat and say where you're from, which company you work for. So you have the chat tab, so feel free to interact with us. And before we dive in with Axel, just let me explain a little bit about the Livestorm environment so that everyone is familiar with the platform. So first of all, we will submit 2 polls during the session. So basically, this is 2 simple questions with multiple choices that you will be invited to answer. So it will appear automatically on your screen. And there's also a questions tab at the bottom of the chat, and that's where you can ask your questions during the session. You can also upvote questions that you find interesting from others, and we will prioritize those during our Q&A session at the end. It's also possible to turn on English subtitles by clicking on the captions tab in the bar right below the video, if it's more comfortable for you to have the English subtitles. And at least feel free to use the chat as much as you wish, because interaction is always welcome. So yes, let's go with the presentation. Axel is going to walk us through 30 years of rail logistics evolution at BASF. So without further delay, Axel, the floor is now yours.
Yeah, thank you very much, Aurore, for this kind introduction. Dear gentlemen, dear ladies, dear colleagues, I'm very happy here to share our experiences concerning the future of our supply chain and our logistics here with you, and give you some insights what developments we did at BASF in order to get our system running. We have here, as Aurore already mentioned, we are a global company, and we have a very strong backbone here in Europe. And our biggest site here, where I'm sitting here and giving the talk, is in Ludwigshafen. And since we have Ludwigshafen and several other big sites where we have our chemical production, we are very dependent on intra and inter-site logistics, which means getting our materials and our products transported within the sites and between the sites. And as you can see, we are basically having a modal split. Most of you might have similar modal splits. We try to get our volumes between the sites via ship, via rail, and via road. And the split is more or less 1/3, 1/3, 1/3. 1/3 on road, 1/3 on rail, and 1/3 on ships. And this means for a huge site like Ludwigshafen that we have to deal with about a little less than 2,000 trucks daily, a little bit more than 400 rail cars daily, and 15 ships, and getting these orchestrated in order to get the materials transported. This means in Ludwigshafen, to get these done, we need some infrastructure, and we have here 3 ports and 2 rail terminals and lots of roads and tracks in order to get our different factories here on the site delivered with the products and starting materials they need.
So yeah, ready for the question?
Yeah.
Yeah, we have a first question for you. So let me publish. Yeah, this is how, so you can, you should be able to see that. How familiar are you with automated guided vehicles in logistics operations? So I'll give you just 1 minute to answer. Does anyone can see the poll? Okay. Yes, the results. So, okay. Most of people know the concept, but never use them. So, Axel, you can just keep going on your explanation.
I give my best. Thank you very much. So, most people might ask, well, chemical, I know BASF, I know the BASF company, but they are selling chemicals. Why are they really in the logistics business or even the rail business? And we were very early in our days concerned about having efficient rail processes, because we only can sell our chemical products and then our solutions for our customers around these chemical products if we are able to transport them in a efficient, cost-efficient, and fast and speedy way. And therefore, since the beginning of 2000, BASF was trying to shape the rail logistics scenery here in Europe, and was one of the first. You see some history here, what they did in the last 25 years. Was one of the first to start to push the liberalization of a European rail market. So BASF and partners, we founded one of the first private railway undertakings around 2000. At that time, it was called Rail4Chem, in order to support the liberalization of a European rail market, get it more flexible, get more players into the market. And this was quite successful. And to be honest, nowadays we are not part of this game anymore, because after the liberalization was successful, we sold our shares from the company in 2008, and it's now a part of Captrain, as you might know. But the task was very efficient, and we see lots of private railway undertakings now in the market, which helps to get the market cost efficient and flexible. And at the same time, we didn't only start to have our own railway undertakings, but we started to heavily invest into infrastructure. And the first thing we did, starting from 2000 on, was to invest in combi terminals, which close to our major sites, in order to get the combined traffic more efficient and in a faster way for our big sites. And we started here with other partners, with the KTL in Ludwigshafen, which was started to build in 2000, and then in 3 stages up to 2012. And we started with a second terminal near our site in Antwerp around 2010. The whole time, in parallel, we started to develop some concepts in order to have an efficient fleet management of our mobile equipment. How to use our mobile equipment most cost efficient in a flexible way. We did some pooling. We developed our own service units. So we have an own workshop, we have an own cleaning station, and we tried to shape our railway environment in the way that it was most handy for us. And in the middle of 2010 years, so around 2015, we started to really get the next stage, to get to the next stage, and we started a new 75 tons segment in intermodal transport, which I will share our experiences in the next slides in order to get really new advantages of a rail system, and in order to get more flexibility and more resilience to the whole system. Perhaps a last word on digital automatic coupling. So as we believe that this way of having new building blocks for our rail system will help us as well in the transformation to the new digital automatic coupling in the next years. And we started 2 or 3 years ago really to have some closer look into the whole thing, and especially in the transition phase where you have 2 coupling systems on the market, which will be rather difficult for at least us in the chemical industry. But now let's have a look on what we started in the last 10 years. And this is thank you, Aurora. This is a picture as it all began. It is around 2000. You see one of our first rail for chemtrails when we started liberalization of the market. At that time, we had still snow in Europe, so it's already some years ago. This, as it all started, as I show you, and then in the middle of the 2010 years, we started with 3 really important topics for us, and the first one is shown on the next slide from Aurora. In order to get our major sites connected in a very efficient way. As I said already, we heavily rely on rail transport, and that is combined traffic. And as an example, I will use, for example, our 2 biggest sites here in Europe. It's Ludwigshafen, as I already shared, as the biggest site, and Antwerp as the second biggest site of BASF. I don't read you through all the data, but you see there are lots of tracks and streets, and we have to transport lots of tons of product from one side to the other. And the specific for all these sites is that you have several distinct production plants on these sites. So you have to interconnect the production plants on the site, and you have to connect the 2 sites with each other in order to get our production lines running. And the building blocks we were developing in the first 15 years of this 2000 years were the 2 intermodal terminals you see below. So the intermodal terminal located in Ludwigshafen and the intermodal terminal combinant in Antwerp. And we are running block trains between these 2 terminals in order to get our products transported, and some people call it as a sort of rolling pipeline. And at some stage, we were thinking about different ways when using classical rail tank cars in order to do this transports. And this was where it all started around 2015, when we started to cut our rail tank cars in half. And this was the first innovation BASF launched at that time, that we developed a new sort of tank container. It's called the BASF Class Tank Containers, which are something in between the classical rail tank car you see on the left, with around 60 tons of payload, and the as well-known smaller ISO tank container, which are smaller, which are all used all over the world, but which have a lowered payload of only around 25 tons. And the simple idea was to take the classical rail tank car, cut it in half, and have a huge tank container, a BASF Class Tank Container, as the upper part of a former rail car, which you can more or less store and handle like a classical ISO container with all the flexibility and all the disadvantages you have for this system. And you have a lower part, the flat car, which you can then use to transport these sort of tank containers on the classical rail tracks as a substitute for the rail tank cars. And this system gave us some clear advantages which were very important for us at that time. The first advantage was some legal issue. At least in Germany, you are not allowed to store loaded tank rail car wagons for a longer time. So if you have chemicals in there, hazardous chemicals, you are not allowed to let them stand around for days somewhere in the environment. And it was quite an issue, getting logistics always more complicated to really have this series of transports that the chemicals never had to stand around for several days. And this type of cutting the classical rail tank cars in two parts gave us the opportunity to store the upper tank of a rail car in a legally more reliable and cost efficient way, because in these cases you did not have to store the whole rail tank car, but you were able to store the tank alone, which makes it much easier and cheaper to store. And a beneficial effect is that you can, at the time when you store the upper container, you can still use the flat car for doing other transports, which gives you some monetary benefits. So basically, we tried to combine the best of the two worlds of the ISO tank container and the rail tank car. So for the ISO tank container, the flexibility in handling and storing, and for the rail tank car, the bigger payloads in an intermediate system, which is the BASF Class Tank Containers and the flat cars, which we developed and which we are now using quite heavily now. A second building block for the whole system is to improve the so-called last mile for our BTCs, because as you might imagine, since they now weigh around 75 tons and not only 30 tons, like the ISO tank containers, you could not really handle them with normal truck equipment. And therefore, we developed our new automated guided vehicles, calling AGVs, which are autonomous vehicles which are able to transport our BTCs on our site. So you see here in the picture, you'll see two examples of these AGVs. They have the possibility to have a payload of around 78 tons, which are distributed over 32 wheels. It's very important to have that much wheels because we are using the normal streets. So we have to be sure that they don't get too much weight on the street. And when we use 32 wheels for 110 tons, you have per wheel more or less the same weight like for a classical truck. But the really exciting thing about these automated guided vehicles is that they drive automatically. So you don't have a driver there. They are really driving on their own on our site in the normal traffic with all the other participants of our intra-site traffic. And for sure, they are not all on their own at all, because so you have a control tower, a control stands somewhere remote, because we don't rely only on the technology of these vehicles. We still have some people, some human beings to take control over these vehicles, and they have the possibility to supervise them from a remote control room, which is located at one position of the site. And in the case of emergency, so if you, for example, have a parking car, when a car doesn't park at some position where it should not park, they have the possibility to take over, so to stop the automatic mode take over and have really some remote control, so they drive when they are able to drive the vehicle from the remote stand around the obstacle, for example, about the parking car or whatever, or if there's some building going on. And once the vehicle is on the proper route again, they can switch back to the autonomous mode, and the vehicle can drive on its own to the destiny it has to go. Usually it's a loading station of a plant here at our site. So this was a second building block for our concept for the future. Let's call it a little bit like that, to improve the last mile, that we are not only dependent on rail transport for this huge large tank containers, but that they have a second and very efficient way to get it the last mile to the plants we have. The third building block was building a fully automated tank container storage yard for exactly these huge BASF tank containers, but as well the classical smaller ones, the ISO tank containers. This was built from 2015 on. So you see, it was all the three building blocks were more or less developed at the same time, and this was important because they really are closely interconnected with each other. They are really adapted to each other, and this container storage yard, we have it here on our side in Ludwigshafen, is fully automated. So the cranes are running automatically. There are no people working inside this container storage yard. We have a capacity of about 22,020 food equivalents, and the really exciting thing is that we are able to store our container six-fold. So we have really stacks which are 6 containers high, which is, I think, I don't know if it's world champion class, but it's for sure higher that you might see in normal tank container storage yards. And you need some special tank containers for doing storing it six-fold in order that they can get the weight of the containers above them and don't get squeezed in the lower layer. But I told you in the beginning that one of the major reasons for the development of the BASF Class Tank Containers was to get an efficient possibility of storing them. And when you have a look at the left picture here on the transparency, you can see what I mean with having an efficient storage. You need much less space for doing the storage when you are able to stack the containers. You can't stack really rail tank cars in an efficient way. You don't have, so when you are storing hazardous chemicals, you have to take care that the area you store it is properly built, so that you have some concrete there, so that the chemicals can't get to the soil or water in case of emergency. So you can save lots of area to be put with concrete and some suitable sewage system in order to get this environmentally friendly, which is as well saving some money if you have just to build this concrete area for 1/6 of the area and not for the full area. And you see, as long you store the tank containers, you don't need the flat cars. So at that time, the tank containers are in our storage yards. The flat cars can do our job, can do their job with our tank containers, which are on their journey to our customers or to our plants. And bearing in mind that the sum of a tank container and the flat car costs are in a similar range as the costs for a rail tank car, then as long you don't need the rail car and it can do some job other way, you don't pay for the flat car. And this is where the beneficial, the improvement in costs comes into the game concerning this sort of tank container storage. We have 3, so it's an intermodal tank container storage. We have 2 cranes, as I said already, fully automated. We have 3 tracks under the cranes where we can put together our trains to get the tank containers transported to our plants and customers. And we have 8 loading bays where we can put the tank containers on our AGVs or as well on usual trucks. So as long they are empty, the containers, for example, going for maintenance, going for cleaning, they are not so heavy anymore, and you can use ordinary trucks to transport them. So this was the third building block of our concept, which we put together and are running now quite successfully for, in total now 5 years. And we made a small film in order to give you an idea how it looks when in reality, how these 3 building blocks are connected with each other. And Aurora, starting with film, thank you very much.
Yeah.
BASF Class Tank Containers, short BTC, combine the best of 2 worlds. The new tank containers have been allowed in Europe for road and rail transport since 2015. The WorldFoot's largest tank containers, weighing up to 75 tons when loaded, have a similar volume to tank wagons, but with detachable rail wagons, they can be used as flexibly as intermodal tank containers, which are half the size. On the main run, BTC are carried with especially light and quiet rail wagons, while on the first and last mile, they're transported without running on rails by other newly developed autonomous vehicles, the Automated Guided Vehicle, or AGV for short. Rail freight transport therefore benefits from autonomous driving on the road and becomes faster and more flexible. Compared to tank wagons, up to 4 days are saved in transport time with the new system. The interface between rail transport and AGV transport is a fully automatic tank container depot with a storage capacity of 2,000 20-foot equivalent units. BASF Class Tank Containers are stored here with up to 6 stacked on top of one another in a space-saving, quickly available and cost-effective manner. By using BASF Class Tank Containers, self-driving vehicles and the fully automatic tank container depot, logistics become faster, more flexible and 25% cheaper. It's an incentive to relocate more goods onto rails.
Go back to the presentation.
Yeah, thank you very much. Well, I think sometimes a small film explains more than 1,000 words, or at least I tried to visualize what I talked to you before with this film. And in the end, I mean, you see some conclusion of the whole thing. So we started in the upper row with block trains between two intermodal terminals in Ludwigshafen. So here it's a KTL. And recombinant in Antwerp with intermodal block trains in order to get our rolling pipeline, our trains running. And this worked very well for us in the first 15 years of the 2000 years. And when we started, and this is the row below, the second row, we started around 10 years ago to explore the 70-ton segment, as we call it, and not the 75-ton segment on classical rail tank cars, but with our BTCs. And this is now where we heading for. We have at the moment more than 1,400 of BTCs on duty. So we as BASF run at the moment 1,400 BASF Class Tank Containers. We did not substitute all rail tank cars for sure, and we see the BASF Class Tank Containers as an additional building block for an efficient rail system. We will never be able to substitute all our rail tank cars, and this was not the plan from the beginning, but we have now another way, an additional way of doing our logistics operations and transporting our goods. And these rail tank cars are now especially on the way on our sites, so the intra logistics on our sites, but as well on our block trains between the huge chemical Verbund sites. So we have Antwerp here, but we have as well Schwarzheide in Germany as a second Verbund site, and you more and more see tank containers on these block trains, where we used to see only rail tank cars. And we see as well that other players, apart from BASF, are now investing in the 75-ton sector segment. So there are other terminals, when the terminals which are somehow close to BASF, like Component and Ludwigshafen, where it started, but we see the terminal in Hamm, who is able to now handle 75 tons containers. We have a first terminal now in Duisburg in the harbor, which are able to serve the 75-ton segment, and we are just at the beginning of refurbishing our KTL in Ludwigshafen as well, and there will be some 75-ton cranes as well, because I mean this is important. It's nice to have these huge tank containers, but as long as you can't handle them in a filled state, they are nothing more than a rail tank car, when you can't put them from the flat car and put it on the flat car again. So as we think it's a big success for us, we are able to store our chemicals in an efficient way. We are saving costs due to this improved storage, and we have now lots of these new tank containers on service. We see as well some developments in the European market, but other players get into the 75-ton segment as well. So we see some containers for grain from Tatra, and we see some other containers for scrap, which somehow try to do the same philosophy like we did for our chemical tanks. Yes, I think we have enough. And
yeah.
This sounds all great, and we are very happy with the developments we have made in the last 10 years, and we made our logistics more resilient and more having some more additional great degrees of freedom in order to handle it. But we as well, as you, if you are playing in the rail game here in Europe, we see some challenges, as you nowadays call it, and the real problem is that we here have really some prerequisites to have successful intermodal transport, and we have really struggled hard to get this prerequisites really in reality. So we have. It's not always given that the cargo arrives on time here concerning our rail services. We have really big issues with standardization across Europe. I mean, I just mentioned the digital automatic coupling, which will come in some years from now on. It's really a tremendous effort to get these standardization of equipment across Europe and across all players done, and done in a somehow timely manner. We still have, and we still see a high payload difference for the last mile. You don't have AGVs and heavy duty trucks somewhere, and it's still a problem how to cover the last mile. And we would wish in our company, but as well concerning regulations and concerning our political system, that innovations are somehow got faster on the track. So it now took us that I'm able to talk to you. It took us almost 10 years to get these things running, and this is a long time in our world today. We need as well some money for having still. So in the modal transport network, you need some infrastructure. And we, at the moment, at least in Germany, we have really some subsidies for building this infrastructure and renovating this infrastructure. So the first terminals we have in Europe, they are now 20, 30 years old or longer, and they need some renovation at the moment. We need some subsidies if we somehow want to manage the introduction of a digital automatic coupling, which will be very expensive and will make very efforts for all the players in the railway market. And the most important thing is, and this is what makes rail transports, at least for BASF, increasingly difficult, is that we need a reliable infrastructure. So we have in many parts of Europe, in Germany, very old infrastructure, and we are having a hard time now. Major renovation work is going on, major repair work is going on, but this always means you have to use some alternative routes if they exist. This takes additional time, this takes additional effort, and these are the challenges that we see for the upcoming years. But we hope and we think that the developments, the building blocks we developed in the last 10 years will help us to tackle these challenges. But in total, it's not an easy time for the railway part of the modal split, and we have to struggle all in order that it still stays reliable and cost efficient in the future. So I think this was more or less my last transparency.
Yeah, thank you very much, Axel, for all the insights. It's impressive how far BASF was able to get railway operations automated. So before taking the questions, there is to conclude the presentation, last question from us. So I'm just publishing the poll so you would be able to see the question. So where does rail digitalization has the most value in your operations today? So give you also a minute to answer. And okay, so we have this is really balanced between all the answers. Okay. Well, now we have 36% for transport and execution tracking. Okay, so you need visibility and tracking. Great. So I think you could just keep answering that. And so, well, thank you again, Axel. Let's take the questions so as a reminder, you have a questions tab just below the chat in which you can just write your questions and vote others one if you find them interesting. But I've seen just one in the chat. There is someone asking for more details about the digital automatic coupling. If you want to answer, Axel.
Yes, concerning the digital automatic coupling, I mean, there are lots of programs and lots of work going on at the moment. We as BASF were participating in some of this work. So we in my workshops, we had some tests of how to get old rail tank cars and as well our flat cars, how to build to get rid of the old screw couplings and build in at least the prototypes of a new digital coupling. We made some tests with our BTCs, our flat cars, and our marshalling humps, which was a major interesting thing for us. But this is the technical perspective. So I think the technical perspective is already quite demanding, as at least when you have a look how much workshop capacities you have in the European market and what workshop capacities you need to get the transformation done. We are now developing concepts not for the day after the introduction of a digital automatic coupling, because when you only have one system around, and this is when the world is quite easy again. Let's call it like that. But you will have a transition phase about 5 years, 3 years. The optimistic say 3 years. We believe it's more 5 years. Having a look at the workshop capacities, and this is what, depending how your infrastructure looks like, is a major challenge for us, because when you have an infrastructure like we have in Ludwigshafen, which is historically grown, which is quite narrow, where you have a loading base, loading stations in quite close proximity, and you don't have only block trains, but you have lots of single wagon transport. When it gets a real challenge, how to survive in this phase where you have 2 coupling systems around, the old screw couplings and the new digital automatic couplings. And we are now doing concepts. So there are several concepts from the community with buffer wagons and so on. But all these need space and they have additional costs. And we believe that our BASF Class Tank Containers with the flat cars can be one building block for companies like us who have crowded infrastructure, who don't only have block trains, who have lots of single wagon, who have very much different customers to get through this transition phase, because this gives you the opportunity with an additional degree of freedom to decouple the tank with the and when the tank means the product from the coupling. When you have a look at the classical rail tank car, the coupling is fixed to the tank because it's all one unit. And when you have chlorine in the tank and you have or chlorine is perhaps not the best example, but if you have monoethylene glycol in the tank and you have screw coupling, then your monoethylene glycol is inevitably fixed to the screw coupling. But if you have a BASF Class Tank Container, your monoethylene glycol in a BASF Class Tank Container, you can choose the flat car you need, and you can change couplings in a combi terminal or wherever you have a crane. And we think this is really some building block which might be crucial for us or other industry who has a portfolio of customers and plants like we have to get the transition phase done in a rather efficient way. So this is what we left a little bit the technical developments and to the community. We are following this, but we are more now in making concepts how to deal with the transition phase with our crowded sites and the plethora of customers we have to serve in these times where you have 2 systems around.
All right, thank you, Axel. We have other questions, so I will take the one from Tanya. What exactly was digitalized and how is BASF working with it? Were the processes optimized through digitalization, and will anything else be presented on this topic?
So digitalization is something which was always in focus during the 10 years. But to be honest, so what we don't have here is one system which fits for all modes of transport and this as a single point of truth for AGVs and rail tank cars and trucks. We have several subsystems for these modes of transport which have very efficient real-time connections and communication interfaces, and this helps us to get some of the processes digitalized. So we have lots of manual steps like for getting things into the storage yard, making transports and digitalized in an efficient way, but we are still working on that to get it improved even more. So we have still lots of manual work around. So we were quite successful to get the the hardware automated. So we have an automated tank container storage yard. We have automated guided vehicles. We have some digitalization around, but we are not there where we want to be honest. And we are planning to migrate to the new SAP system in the next years, which doesn't make it so much easier. So it's a constant struggle, but I think we got a decent way in this direction, but we are not there where we want to be.
Okay, thanks. Just last questions, because I can see the time running. The AGV system operating in mixed traffic with other vehicles looks impressive. What was the hardest operational challenge during integration? Was it safety, regulatory approval, coordination with existing traffic?
Yeah, the hardest thing was to be honest, the safety issue. So, and it is not a regulator in the first case, a regulatory safety issue, but as well here from the site. No? So it's a system which transports hazardous chemicals, where you don't see a driver and it runs there along the streets. So we had very long discussions, and this was one of the major reasons why it really took 5 years from the first transports to the normal operation to get these discussions settled, to get these discussions to a result where everyone can live with it. And to be honest, we are still not using the full technical potential the vehicles would have, because we are still in the ramp up of automation and digitalization due to safety reasons. So the vehicles could do more, could be more efficient, but we are still restricting ourselves a little bit what we want them to do, and where we say, okay, no, this is a point where we as BASF, we as a site Ludwigshafen still want that a human being is involved. So it's a little bit like autonomous cars. No, they technology-wise they can do more than we as society want to do them.
Okay, thank you. Just we have a last question, just maybe short. What is the main IT system behind your digitalized solution, such as SAP, EWM plus TM Advanced, or what else?
So basically, BASF as the most others, we as an ERP system, which is our single point of truth, is SAP. And some of the modules which we created, for example, for the tank container storage, they are still in SAP, but for other solutions, like for our AGVs, but as well for sure the fully automated tank container storage yard itself, it's some customized solutions which you can't get on the market. So they were specifically generated or developed for the purpose they have, and we have as well an own rail system called RCMS, but which is as well something which we developed over the last decades in-house.
Yeah.
Sorry for that. So you can't buy this.
Yeah, very customized. Well, thank you very much. I think we'll keep going. So yeah, we are close to the end. So if you'd like to watch the webinar again, the replay will be available within a few hours now. You will receive an email from me with the link and access to today's discussion. And just before we close, I'd like to share with you the next RailTech Master Class, which will be on May 6th. So I will welcome Sebastian Sperker from Rail Cargo Group, who will present an innovation that could transform single wagon load transport in Europe. So save the date in your agenda. And if it's fine for you, Axel, in case you have another word to share, thank you everyone for being part of this discussion, and have a great day.
Yeah, thank you very much from my side as well. I hope I could give you some insights of our experience, share some honest words, what worked and what did not work not so much, or where we still have some stages to go. Thank you very much for your interest and your support. Thank you.
Well,
and thank Aurore for the perfect setup here. Worked very well. Thank you very much.
Thank you. Thanks to you too. Well, have a good day, everyone, and I hope to see you again in the next RailTech Master Class. Bye-bye.